Hi, I'm diCicco, Senior Editor of Sky and Telescope magazine here in Santa Clara, California for the 2013 Advanced Imaging Conference, AIC. And I'm speaking now with Rick Hedrick, President and founder of PlaneWave Instruments. I've spoken with Rick before at these events, and it becomes easier to introduce him each time because PlaneWave is now one of the best known names among astronomical images. Their telescopes are around the world, and they've taken some of the finest astronomical images anyone has seen. And Rick has some interesting products he wants to show me. What do you want to do?
Well, let's start off over here. Brand new, we're just introducing here at this show, is the CDK14. And we've for a long time had, you know, a gap in our line. We went from the 12 to the 17. And so we've been planning this for a long time. And we weren't sure if we were going to make a 14.5 or a 14. But what we decided as one of the main criteria is we wanted the telescope to be lightweight enough to fit on the really popular mounts that people have, the affordable popular mounts like the MX here by Software Bisque, or like the AP 1100 from Astrophysics.
All right, so we're looking at mounts that are not only popular, but these are very good astrophotography mounts that are also portable. So you're looking at a fairly substantial system that also could be used quite effectively portably.
Right,
All right.
So yeah, the telescope weighs only 47 pounds. So our real goal was to try and beat that 50-pound mark. And some of the features are, we have, well, I'll tell you first, the telescope covers a 70-millimeter field, and its diffraction, that's the
imaging circle.
The imaging circle, which is diffraction limited across the whole field. It has very small amount of vignetting. The system is f7.2. One of the cool new features we're offering is the backplate here is actually removable. So this separates out and the whole backplate comes off, so you have access to the primary mirror for cleaning or at some point when you want to, you know.
So when the backplate comes off, the whole mirror comes out with it. You've got the whole assembly in front of you. All right, I'm going to back you up for a second because you said a 70-millimeter imaging circle.
Yes.
That is very large because the biggest chips today most people are using are the Kodak 16803s. Those have a 52-millimeter requirement.
Right.
So you've got more than adequate.
We'll talk about other telescopes in our line. We've been kind of going through and revamping the line, and all our telescopes are having 70-millimeter fields, diffraction limited across the whole field.
Looking for the next generation of detectors.
Yeah, we're getting ready for the future. Chips are getting bigger. The other thing we are considering is making a reducer that takes a 70-millimeter field down to a 52-millimeter field. It's a real high-performing reducer, and as I said, it takes you from a 70-millimeter down to 52-millimeter field. So it's like buying a 70-millimeter chip. It's the same number of photons now being put onto a 52-millimeter chip. So you can either buy the bigger chip or you can buy
put a
the
reducer in.
Now the reducer is designed to have a lot of back focus, and it is an expensive reducer because there's a lot of components in it, a lot of glass in it, expensive glass. But it's very high performing. You know, another innovation I'd like to talk about is, and this is a really, every once in a while you do something that's clever and you're really proud of it. It's a very simple thing we've done, but it lightweights our system, and it's a much better way of producing something. Have you ever heard of 3D printing?
Of course.
Yeah, okay, well, what we're doing is, the baffles in the telescope are generally, we make them out of aluminum, they're large, there's a lot of machining, and in order to get little bafflets inside there, there's assembly, there's gluing. What we've done is we've 3D printed the baffles on this telescope, which it makes them about 1/7 the weight. And you actually can make shapes that there's no way you can machine inside, and we can have these bafflets designed to suck in all the light.
Optimize it.
Yeah, just totally optimize. You can go in the ray trace and design the best optimization, and then you can make it. And it actually costs a little bit less than machining them. So for our kind of products, which are, you know, fairly low volume, we can actually, it makes sense in a production environment to actually 3D print these. They're ABS, they're really, they last in UV light, and they do well in freezing cold, and they're the best shape you could actually make.
Yeah. In other words, you don't have to make any compromises because the machining would be too difficult for a low volume part.
So it's a great use of technology. And, you know, I think people in our industry are going to start doing this because it's such a great idea.
And it started here.
I just want to say it started here. Everyone go for it because it's a great idea, but, you know, PlaneWave.
All right.
Anyway, so 14 is a new product we're very proud of, very excited.
All right. So I can see you've got a couple of features on the front end here.
Yeah, so this telescope comes pre-wired for our dew heater. So it has a temperature sensor on the secondary, and it has a heating pad. It also has heating pads behind the primary mirror and temperature sensors. And then, since it comes pre-wired, you can buy as an accessory our Delta T, which is our dew heater controller. And with this, you would just plug it in, and the telescope's already pre-wired. Right. So it's very convenient for people. So what happens is, if you don't have a telescope pre-wired and you want to add the Delta T, you have to actually send a telescope in to pre-wire it. So we've decided with the 14 to pre-wire everything so it's ready, because a big percentage of people are buying Delta Ts.
I was going to say, this seems like a feature that people would want. And you can set the temperature to keep the mirrors just above ambient. It will track ambient.
Exactly.
And it will control the mirrors.
And it runs with our same software that controls our mount, controls our focuser, is PWI3. So it's all controlled. You get a screen that shows you all the different temperature sensors on the telescope. And you can turn the dew heaters on. You can set them to turn on automatically at certain delta temperatures between ambient and the primary, etc.
So I know from experience of living in the Northeast, particularly at this time of year, dew can be a huge problem. And to have this kind of control where you can just adjust it to just keep the dew off when necessary is great.
So you know, it's funny that it's taken us a long time to make a dew heater, and we live in Southern California. It's a desert, it's dry, and we kind of didn't really believe people had dew, but they finally pummeled us into submission. We believe it, okay.
I can send you some in a bottle some night if you really need to see it.
Yeah, if you really need to see what this is, yeah.
So I noticed in the back here that it looks like the 14 takes many of your standard accessories. You want to show me what you got?
Sure. Right now we have, this is our IRF90 rotating focuser. So this can take our standard Hedrick focuser, or it can take the IRF90 rotating focuser. Again, we need the large focusers because we've got the 70mm field that we're covering.
All right. So you've got, obviously, your in and out focus adjustment, and you've got your rotation if you want to turn it. If you're off axis guiding, you do pick up guide stars. And
we also have increased back focus. So it's from the mounting surface of the focuser, it's about, I think it's about 11 inches of back focus.
Well, I can even see here from this adapter, you've got plenty of room here for filter wheels, AO units, all kinds of stuff that you want to put in.
Right.
And I'll have to admit, several years ago when reviewing the 12-inch telescope, having solid adapters in here were just remarkable in terms of the rigidity between the telescope and the camera. It's just a superb system.
So yeah, we call this our secure fit adapter. So everything bolts on. We try wherever we can to bolt onto everything because we want it to be rock solid.
Right.
And then all our focusers run on lead screws, so there's no slippage, so you have very dependable, repeatable focus. Yep. And as you're moving around, changing the gravity vector relative to your camera, your focus isn't shifting because things are sliding or because they're on friction. Everything is bolted and running on lead screws.
And worse yet, something slides out and falls on the floor.
Oh yeah, right.
Very good. Anything else you want to tell me about this, or do you want to move on to some of your other products?
Yeah, let's move on over here.
All right.
So
something a little bigger.
Yeah. So we kind of have. We actually have this is a new unit we made for a customer, and we decided to make it a product. And it's a Tandem Bar that holds multiple telescopes. So here we have our 17-inch, and here we have a stellar view refractor, and here we have our 14-inch. And these two over here, you can actually adjust and center them on this telescope here.
So these mounting brackets actually have the ability to tip the telescope a little bit up, down, left, and right, so they can all be co-aligned with the same.
Exactly. And I would imagine, probably you're not going to put two big telescopes like this. It's fun to do for a show. You'd probably have like a 17 or 20 in the middle, and probably two decent-sized refractors. If you want to have two refractors, it's really not a good way to mount them. And the other thing, if you're mounting large refractors on top of the telescope, the moment of inertia is is much bigger.
Throws a lot more counterweight on.
Exactly. So
keeping everything low is excellent.
Right. Another neat thing that we came up with is this device here, and this is for setting the balance. And really, it's probably better to look at the one in the back here. If we move back here, we can see it. So what this does is these telescopes are large, and if you have to do balancing on them, it's difficult because someone's got to hold the telescope while you loosen
the dovetail.
So this holds it in place, and you just take a ratchet and you move these big heavy telescopes, and you can move them. Very fine adjustment.
Boy.
We just used this on a 24 on an install last weekend, and it was, usually there's 3 of us holding the 24 while you loosen the saddle, and then we have to push it up a ½ an inch or lower it a ½ an inch. This way is one person can do it. That's the whole idea is, someone's out there by themselves, and they want to adjust their 24. It just can't be done if you need to move it. So this thing allows you to do that. We also allow for sliding counterweights. This is a standard Lost Mandy dovetail here, and you can put counterweights here if you wanted, just to do some other fine balances as you're adding and removing.
That's actually great, because I was going to ask, it looked like this is removable. You can put it on just to move the scope, but it's actually worthwhile to keep it on. And to go back, I can speak again from experience to say it's a little scary even to loosen the dovetail when you go to slide this stuff, because you see a big telescope kind of rocking in the mount there.
Yeah,
so
certainly.
That's a great feature. Plus it gives you the ability to really get the precision balance.
Right.
So that's really nice.
Yeah, and then on top of all of this, we're on top of our A200 HR mount. And this is our German equatorial mount.
Yes, which is becoming more and more popular all the time.
Right, we've got this in many remote observatories. It's really optimized for that. You can run all the cables through the mount. These covers come off. You can drop an extension cord, right down through the mount. It has axis encoders on each axis. Those are high-resolution encoders that are directly coupled to the right ascension axis and to the declination axis. And that gives us precision pointing and precision tracking. All periodic error and errors in the whole gear train are a thing of the past.
Yes, this is a trend now, and you guys have got it instituted where you're really running against an encoder, so it completely eliminates periodic error.
Right, and it used to be in the past that axis encoders were only on the most expensive mounts that you'd never see at shows like this or kind of in our industry. And it really is with the A200 mount, was really the first mount in kind of in our industry to have axis encoders and being used like this. And now it's starting to become a trend in the industry. And it should be, because axis encoders completely change the performance of the mount. They perform, we originally made this mount and we were going to offer it 2 ways, because the encoders have an added cost. But when we saw the performance difference between the two, we decided, PlaneWave is only going to go with axis encoders. That's what we're going to offer the best performance. So.
Right from the get-go.
Yeah. So the other thing I want to talk about was we had talked about the 70mm field on the 14,
yes.
And I mentioned some other telescopes. Well, our 17 last year was redesigned also. We changed our the way we hold our secondary. The secondary mirror obstruction got larger, so we'd have less vignetting as you go off axis. And we have now a diffraction limited field across the 70mm image circle. Just like, as I said, we're trying to get that across, on all the telescopes.
And you'll be making focal reducers for this as well?
And the same idea, yeah. And then the other things, here you have an example of a baffle that's made out of aluminum. That's a 7-pound baffle. Even on our 17s, we replaced them with the 3D printed ones, and it's a 1-pound baffle now. Wow. So it makes the telescope way less, and secondly, it puts less stress on the mirror cell that's holding the mirror. The same thing we've done with the secondary. This particular one, our show scope, still has the aluminum ones on it, but it's a good example. The other thing is that aluminum, this has not been painted, it's just anodized, but aluminum is not very good in the infrared.
Yeah.
So the plastic is much better, absorbs the infrared much better. The other thing we've done is we've added 4 fans around the light shroud to blow across the primary mirror.
Right across the surface.
Right across the surface of the primary mirror. We've done that on some of our larger telescopes. And when we were redesigning this, we decided to do that here too. Are
you doing that to aid in the cooling, the ambient cool down time? Or?
It's both. It helps cool down the telescope, and it removes any boundary layer that gets over the primary surface as it's cooling.
So that really started with the professionals, and it's now moving down into the amateur scopes.
Yeah, and I remember, many years ago reading Sky and Telescope articles about that exact thing back when we were making Dobbs, and people wrote articles about blowing across the front to get rid of the boundary layer.
And I was equally amazed to learn when the professionals were saying, yes, we actually see that 2 millimeter surface layer of air across the front of the primary is where a lot of bad seeing originates.
Right,
it's like amazing.
So let's go over and take a look at the 24.
All right.
So as we were talking about with the other telescopes, is the 24 has a 70 millimeter field that's diffraction limited across the whole field. This is f6.5, and it has fans in the back and fans that blow across the front surface of the mirror. We've been selling these, a lot of them on our A200 mount, and on the Mathis fork mount. So it's very for universities, and there's all sorts of, in a big observatory, having a fork mount's a wonderful thing. And we've been working with Mathis. He's added axis encoders to his mount. He's added through the mount cabling, and we're running it with our software.
So you've really designed a package around a fork mount and the 24 inch.
Yes, exactly.
All right, that's nice.
So I'd like to tell you about some other things that we're doing. We're starting to do some professional services. We've kind of started something we call PlaneWave Professional Services, and it's being run by Allan Keller. And so I'd like to introduce you to him. And
All right, well, let's go talk to Allan.
Okay, great.
It seems like my ears were burning.
Hey, Allan, how are you?
Good, Dennis. How are you?
All right, great. So Rick tells me you're going to tell me a little bit more about PlaneWave's professional services.
Yes, PlaneWave Professional Services is a partnership with PlaneWave that will provide customers the opportunity to create their own remote observing site where they can control the telescope over the internet. Now this can be done either through creating an observatory at the customer site, or we've also created an internet network of telescopes.
So in other words, as an individual, I see that people are setting up remote observatories in very dark locations, and I say, I want to have one of those too that I can run from my home. So I could go to you and say, look, I want to do this, but I really don't know what to do, and you could provide me with all that?
Yes, exactly. Setting up a remote observatory is a complicated task, and I think it keeps some people from being involved in the hobby. They want to go to the next level, they don't know how to do it. So what I'm providing is a solution that creates the observatory. I will talk to the client, find out what their goals are, and create the observatory for them.
Recommend what telescope they buy?
Well, yes, of course I'm featuring PlaneWave telescopes, but I'm also going to be working with other suppliers to integrate a system that meets the customer's needs.
So when you get done, I'm going to be able to sit at home with my computer, turn on and log on to my remote observatory and run the whole telescope and everything. And you're going to be the person that gets it really set up for me. So I really don't have to worry about getting all the parts working together. You're the one that's going to get them all to play well.
That's correct. I'm going to provide a turnkey system for the customer.
So what happens if I really don't want to invest in an entire observatory myself? Any option for being able to do this with other equipment?
Absolutely. I set up a network of telescopes, currently a CDK20 and a CDK24, that customers can remote into to do remote imaging at
a rental fee.
Well, at a rental fee, and it's located at a premier location with excellent seeing, excellent skies.
I was going to ask, is it here on the West Coast?
Yes, it is. It's located in the Sierra Nevada mountains at Sierra Remote Observatory.
All right. Curiosity, do they have to be running the telescope in real time? In other words, does it have to be night in California for wherever they are running the telescope, or can they pre-program what it is they want to observe?
They can pre-program what they want to observe, so they can do it any time during the day, and it's a script that will run at night to gather the data that they choose.
Very good.
Well, one of the changes that's happened in astronomy is that you don't have to be near the equipment in order to get the images and do the things that you want. It's really about the data. The data has to be of high quality, taken with high quality equipment. That's what I'm providing. The data service is a way for customers to get data, images, photometry, other sorts of images, even space situational awareness for satellite and space debris tracking. That's the data that we're looking at. I'll be providing a variety of different sensors on my telescopes that provide different types of data streams. It's a multi-wavelength approach to astronomy.
So if I'm even an amateur or a professional that's interested in getting some photometry, say in infrared and invisible wavelengths, I can go to your site and get the data. I can actually acquire the data with your telescopes.
That is correct.
Wow, that sounds really great.
Well, thank you, Dennis. We're really excited about the professional services. We're going to be providing observatory systems as a complete turnkey solution, as well as providing a data network that people can log on to get images remotely.
If they don't have their own observatory.
Absolutely.
Allan, I want to thank you very much for telling me all about this.
Thank you, Dennis.
And Rick, I want to thank you for telling me all about the equipment and everything that you have. And for viewers, if you want to get more information on any of the services or the products that you've seen here, you can go to the website PlaneWave.com. I'm Dennis diCicco, Senior Editor for Sky and Telescope magazine, here at the 2013 Advanced Imaging Conference in California.